Two samples of sizes 13 and 9 are taken from normal distributions x and y with variances sigma x squared and sigma y squared respectively. The two samples give values sx squared equals 24 and sy squared equals 18 respectively. We have to test at the 5% level the null hypothesis h0 where sigma x squared equals sigma y squared against the alternate hypothesis h1 where sigma x squared is greater than sigma y squared. We have the larger nu, which is equal to 13 subtract 1, which is 12. Then we have the smaller nu, which is equal to 9 subtract 1, which is equal to 8. We have s larger squared equals 24 and s smaller squared equals 18. We can find the critical value at 5% with 12 degrees of freedom for the column and 8 degrees of freedom for the row. We can do this using the distribution application. We have an F distribution. Let's change the tail. We have 12 and 8 for our degrees of freedom. We have the critical value equaling 3.2839. We now need to find the test statistic. If we go to the statistics application, then go to setup, then the third option for hypothesis test, let us select the test to be a two sample F test. The data will be selected with variable. Here we have sigma 1 and we want to test if this is greater than sigma 2. Sx1, that will be given by the larger, so that is the square root of 24, and for n1 that will be 12. For sx2, that's a smaller, so we have the square root of 18 and n2 is equal to 8. Let us execute. You can see f is equal to 1.333. If I press the tab key to go to the graph and then press the tools key, you can also see that here. What we can now do is compare this with the critical value of 3.289, and you will see that the 3.289 is greater than the 1.333, and therefore there is insufficient evidence to reject H0. The two populations have equal variances. Two samples of sizes 7 and 11 are taken from normal distributions x and y with variances sigma x squared and sigma y squared respectively. The two samples give sx squared equals 5 and sy squared equals 25 respectively. Test at the 5% level the null hypothesis h0 where sigma x squared equals sigma y squared against the alternate hypothesis h1 where sigma x squared is less than sigma y squared. We can begin by finding nu larger, which is equal to 11 subtract 1, which is 10. We can now find nu smaller, which is equal to 7 subtract 1, which is equal to 6. We have s larger squared, which is 25, and s smaller squared, which is equal to 5. We can find the critical value at 5% with 10 degrees of freedom in the column and 6 degrees of freedom in the row. We can do this using the distribution application. Then we go down to F distribution. Let's change the tail. We have 10 degrees of freedom for the column, 6 degrees of freedom for the row. We have a probability of 0.05. You will find the critical value to equal 4.0599. If we go to the statistics application, then setup, then the third option for hypothesis test, we have a 2-sample F test. Data is variable. We are testing sigma 1 being less than sigma 2. We have SX1, which is the larger. So here we have the square root of 25, and N1, that's equal to 11. SX2, that's a smaller one, so that's the square root of 5. And N2 is 7. You will find the test statistic to equal 5. Let's show this on a graph. If I press the tools key, you can see the test statistic is 5. And what we can do is compare this with the critical value of 4.0599. You see 5 is greater than 4.0599. Therefore, there is sufficient evidence to reject H0, so sigma x squared is less than sigma y squared. 2 samples of sizes 11 and 13 are taken from normal distributions x and y with variances sigma x squared and sigma y squared respectively. The 2 samples give values sx squared equals 1.6 and sy squared equals 2.4 respectively. Test at the 10% level the null hypothesis H0, sigma x squared equals sigma y squared, against the alternate hypothesis H1, sigma x squared does not equal sigma y squared. We begin by calculating nu larger, which is equal to 13 subtract 1, which is 12. Then we have nu smaller, which is equal to 11 subtract 1, which is equal to 10. We know that s larger squared equals 2.4 and s smaller squared equals 1.6. We can find the critical value at 5%. We have 12 degrees of freedom for the column and 10 degrees of freedom for the row. We can calculate this using the distribution application. We have an F distribution. Let's change the tail. We have 12 degrees of freedom for the column and 10 degrees of freedom for the row. Let's change the probability to equal 5%, and that's because we have a 2-tailed test, so we halve the 10%. You will find the critical value to equal 2.9129. We can now calculate the test statistic. If we go to the statistics application, then hypothesis test, we have a 2-sample F test. We have data from variable SX1, that is equal to the square root of 2.4. N1, that's equal to 13. SX2, that's equal to the square root of 1.6, n2, that's equal to 11. You can see f is equal to 1.5. And if we graph, then calculate the f value is equal to 1.5. We can now compare this with the critical value. You can see 1.5 is less than 2.9129. Therefore, there is insufficient evidence to reject H0. The two variances are equal.